to experiment 4, HgCl2 is changing. Experiment 1 to experiment 4, C2O4 minus 2 is not changing. We want to see how does that impact the rate? How does changing the concentration of HgCl2 affect the rate while keeping C2O4 minus 2 constant? So what's happening from 1 to 4? HgCl2 is doubling. If we double the concentration of HgCl2, what happens to the rate over here? 1.3 times 10 to the minus 7 to 2.6 times 10 to the minus 7, we see that the rate is also doubling. So to figure out what the exponent is going to be for HgCl2, we're going to isolate the parts of interest, which is just rate equals the concentration of HgCl2 to some power. So we're going to break this down to just deal with the things that we're looking at in the data table here. So the rate went from 1.3 to 2.6, so we doubled the rate. So I'm going to put a 2 in here for rate. HgCl2, what happened to its concentration? It went from 0.1 to 0.2. It also doubled, so I'm going to put a 2 in here for HgCl2. And then we can list it as 2 equals 2 to the x, so x therefore must be equal to 1. So we know that the impact of changing the concentration of HgCl2 to the rate is a linear relationship, meaning that x is just equal to 1. So if I double the concentration here, I expect the rate to double. If I triple the concentration here, I would expect the rate to triple, etc., etc. So we would say that HgCl2 is first order because x is equal to 1. Now we're going to do the same thing for C2O4 minus 2 in order to obtain the y exponent. So we need to switch up our approach on the data table. We need to find a place where C2O4 minus 2 is changing while HgCl2 is remaining the same or remaining constant. So you can see C2O4 minus 2 is doubling and HgCl2 is staying the same if we compare experiments 1 to experiments 2. So we want to choose 1 and 2 to compare here. Now you can find other ones that this happens in and you can compare them and it'll still work out, but I try to just find the two easiest ones right off the bat. So this remains constant, this doubles. C2O4 minus 2 is doubling. What happens to the rate? We're going from 1.3 times 10 to the minus 7 to 5.2 times 10 to the minus 7. So 1.3 to 5.2. It's not a doubling because that would be 2.6. It's not a tripling because that would be what, 3.9. It's a quadrupling, right? 1.3 times 4 is going to get me 5.2 times 10 to the minus 7. Now, if you can't do that math in your head, you can always just do this in a calculator. And you always want to do big number divided by small number, right? All year we've been talking about always divide by the smallest number. This is no different. You're just trying to figure out what the relationship is between these two numbers. Also, with more complicated problems, pay attention to the scientific notation in this case. And remember that times 10 to the minus 6 is a bigger number than times 10 to the minus 7. So just keep that in mind and watch out for those tricky scientific notations. So we're going to isolate the area of interest to do exponent y. You're going to do rate is equal to the concentration of C2O4 minus 2 to the y power. Our rate quadrupled, so I'm going to put a 4 in for rate. Our C2O4 minus 2 concentration has doubled, so I'm going to put a 2 in for that. And then we're going to put it to the y power. So 4 equals 2 to the y, therefore y has to equal 2. So we're saying that this is second order with respect to C2O4 minus 2. Now what this is saying is that changing the concentration of C2O4 minus 2 is going to give us an exponential relationship, right? This is equal to 2. Y is equal to 2 in this case. So if I change the concentration of C2O4 minus 2, the rate is going to be impacted far more because I'm looking at a squared relationship as opposed to just a linear relationship where x was equal to 1 over here. So what this tells us is that messing with these two concentrations can have an impact on the rate. C2O4 minus 2, changing its concentration will have a far greater effect on the rate than HgCl2 because of the relationships that we see and the experimental data that we just took from. So to do part B, when it says write the rate equation for the reaction, what we're going to do is just fill in our numbers right here. We're going to change x to 1, and we're going to change a y to 2, and that is our answer to letter B. All right, we just circled this for letter B. For letter A, I forgot to just clarify that. What is the order of the reaction with respect to HgCl2, with respect to C2O4 minus 2, and overall? So we would say it's first order for Hg2Cl2, it's second order for C2O4 minus 2. Now to get the overall order, what we're going to do is just add up the exponents and we're going to obtain the overall order. So 1 plus 2 in this case gets us third order overall. So that would be your answer to letter A. I'll come back in 1 second and do C and D with you.